Hey everyone! Welcome back to another deep dive into the fascinating world of science. Today, I'm tackling a question that has puzzled many. Why don't we get our drinking water from the ocean? Earth is often called the blue planet, with over 70% of its surface covered in water. Yet, in many parts of the world, people are struggling to find enough drinking water. This raises a puzzling question. Why can't we just drink ocean water? It seems like the perfect solution. After all, we have an almost endless supply of seawater. So what's stopping us? Why isn't desalination, the process of turning seawater into fresh water, the answer to global water shortages? Stick around, because by the end of this video, you'll have a completely new perspective on one of the biggest challenges humanity faces today. To truly understand why desalination isn't as widespread as we'd expect, let's break it down step by step. At first glance, the ocean looks like an unlimited source of water, but there's a catch. It's undrinkable. Seawater contains around 3.5% salt, and drinking it actually dehydrates you instead of quenching your thirst. Your kidneys have to work overtime to remove the excess salt, leading to even more water loss. If you ever find yourself stranded in the ocean, drinking seawater is the worst thing you can do. But what if we could remove the salt? Desalination is the process of removing salt and other impurities from seawater to make it drinkable. There are two primary methods used today. One, reverse osmosis. Water is forced through a semi-permeable membrane, leaving salt behind. Two, thermal distillation. Seawater is heated until it evaporates, then condensed into fresh water, leaving the salt behind. Both methods work, but they come with serious challenges. Desalination isn't free. It requires huge amounts of energy. Reverse osmosis, for example, needs 3 times more energy than traditional freshwater treatment. And guess what? Most desalination plants rely on fossil fuels, which contributes to climate change. So while desalination provides fresh water, it also increases carbon emissions, making it a double-edged sword. Here's something most people don't think about. What happens to the leftover salt? Desalination creates a highly concentrated salt brine that gets dumped back into the ocean. This can harm marine life, disrupt ecosystems, and make surrounding waters even saltier, affecting fish and coral reefs. Some countries, like Saudi Arabia and Israel, rely heavily on desalination because they have few natural freshwater sources. In fact, Israel gets over 50% of its drinking water from the sea. But even in places where desalination is common, it's still expensive and energy-intensive. Scientists are working on new, more efficient desalination methods, including solar-powered plants, graphene-based membranes, and even nature-inspired solutions like mangrove trees, which naturally filter salt from water. If we can develop desalination technology that's cheaper, cleaner, and more efficient, it could become a game-changer in solving global water shortages. So, should we start using the ocean as our main drinking water source? While desalination isn't perfect, it could be part of a larger solution, alongside water conservation, better management, and new innovations. If you found this video eye-opening, hit that like button and help spread awareness. Don't forget to subscribe and turn on notifications for more fascinating science and tech videos. Tell us in the comments, what's the best way to solve global water shortages? Let's discuss! Thanks for watching! See you next time!